Hello everyone, myself Neha Shah from LG Institute of Engineering and Technology from the Department of Electronics and Communication Engineering. Today I am going to explain you some more properties of Z transform from the fourth unit, which is Z transform from the subject of signal and systems. In the last session, I had explained you three different properties. The first one is linearity, the second one is time shifting, and the third one is scaling in the Z domain. Now, today we will see the next property, which is time reversal. Now, what is time reversal? As you know that time reversal, time folding or time inversion, it means if we are taking the input sequence as x of n, then the time reversal means folding of that sequence, right? So it will representing in the form of x of minus n. So for this property of that transform, first of all we are writing this statement. In the statement we are writing as if we are taking the z transform of x of n, then it will gives you the term as x of z, right? So if we are taking the time reversal property, so for that we have to take x of minus n. So if I am taking x of minus n as the input sequence, so what will be the z transform of this? So we have to find its z transform. So the z transform of x of minus n is x of z inverse. It means if we are taking the input sequence x of n, then its z transform is x of z. Then if we are doing the time reversal, so instead of z we have to take z inverse. Now, if we want to prove this property, so for this we are writing the equation as z transform of x of n equals to x of z, and its value equals to summation n equals to minus infinite to infinite x of n z raised to minus n. It means if we want to find out z transform of x of n, then its equation will be like this. Now we have to find out z transform of x of minus n. So instead of this x of n, we are finding z transform of x of minus n. It means instead of this x of n, we have to take x of minus n. So what will be the step? Summation n equals to minus infinite to infinite x of minus n into z raised to minus n. As I had explained you in the last session as x of something, we have to take this term as any another variable like n. So let we are taking minus n equals to n. If I am taking minus n equals to n, what will be the range of n? If I am taking n equals to minus infinite, so this term will convert in the form of minus infinite. It means n equals to infinite, right? Similarly, if I am taking n equals to infinite and I am putting this in this equation, so the term will be minus infinite. So if I am taking n equals to infinite, then the value of n equals to minus infinite. Now I am putting these three values in this equation. So the next step is z transform of x of minus n equals to summation n equals to infinite to minus infinite x of n z raised to n. Because instead of minus n, we have to take n, right? Now as you know that if I am taking summation minus infinite to infinite or infinite to minus infinite, both will be same. How? Suppose if I am taking the summation of 1 plus 2 plus 3 plus 4, or I am taking the summation of 4 plus 3 plus 2 plus 1, both will be the same. Same way, here we will apply that rule, so the term will be summation n equals to minus infinite to infinite x of n z raised to n. Now this z raised to n term will convert in the form of z raised to minus n. So what will be the term? Z raised to minus 1 raised to minus n minus plus n, right? Now if I am taking z raised to minus n, then the term will representing as x of z. Here we have representing z raised to minus 1 raised to minus n. It means this term will representing as x of z inverse. So this way we can prove the time reversal property. Now if we want to find out the ROC for this term, then for that first of all I am considering the ROC of z transform as in between R1 to R2. Then what will be the ROC of time reverse signal? So for that instead of z we have taken z inverse, right? So instead of this z I will take z inverse. So z inverse will be in between R1 to R2. Now I have to simplify this term z inverse. So z inverse term will convert in the form of 1 by z. Now if I am converting this and simplifying this term, then the final answer of it equals to 1 upon R2 is less than mod z is less than 1 upon R1. It means the value of mod z is in between 1 upon R2 to 1 upon R1. So this way we can find out the ROC of time reverse signal. Now I am taking the next property, which is differentiation in Z domain. It means if I am taking the signal in Z domain, then it will representing as x of z, right? Now if I want to differentiate this, then x is a function of z, so we have to differentiate that part with the help of z. So the representation will be like this: d by dz x of z. So suppose if I am taking d by dz x of z, corresponding to it, what should be the input sequence? We have to find out it. So it will be found by using this property. So in this property, first of all, I am writing the statement for this. So what will be the statement? If I am taking input sequence x of n and finding the z transform, then it will give you x of z. Now we have to do differentiation in the z domain. So the term will be like this: minus z d by dz x of z. Corresponding to it, the input term will multiply with n. Now if you want to prove this property, so for that we will starting with the equation of bilateral z transform, which is z transform of x of n equals to x of z equals to summation n equals to minus infinite to infinite x of n z is to minus n. Right. Now we have to differentiate x of z with respect to z, means we have to find d by dz. Right. So for that, in this equation, I will taking the differentiation on both sides. So this term will convert in the form of d by dz x of z, and this term will convert as d by dz summation n equals to minus infinite to infinite x of n z is to minus n. Right. Now here we will apply the rule. If there will be two summation integration, summation differentiation, then we will changing the order of it. So if I am changing the order here, then what will be the order? This differentiation goes over here and the summation goes outside. So what will be the next step? Summation n equals to minus infinite to infinite. Which term containing the z part will come under the d by dz portion, and which term under the n part it will come under the summation part, right? So we'll representing this as d by dz x of z equals to summation n equals to minus infinite to infinite x of n d by dz z is to minus n. Now here you can see that d by dz, it means here we will using z term only, and n term goes over here in the portion of summation. Now, if I am finding the differentiation of this, z raised to minus n will convert in the form of minus n, z raised to minus n minus 1 degree, means z raised to minus n minus 1, right? Now, if I am simplifying this term, then the term will be z raised to minus n into z raised to minus 1. So, the next step is summation n equals to minus infinite to infinite x of n. This n goes over here and minus is constant, so it will be outside of this summation. So this term will convert in the form of z raised to minus n and z raised to minus 1. Okay. Now z raised to minus 1 term will consider as constant with respect to the summation of n. So this term goes outside of this summation. So it will representing like minus z inverse summation n equals to minus infinite to infinite n into x of n z raised to minus n. Now the next step is z inverse will convert in the form of 1 by z. So the term will be like this. All the other term will remain as it is. Now this term we are representing as d by dz x of z minus z goes over the left side. So the term will be like this: minus z d by dz x of z equals to summation n equals to minus infinite to infinite n x of n z is to minus n. Right. Now as you know that if we are finding the equation of z transform of x of n, so what will be the equation? Summation n equals to minus infinite to infinite x of n z is to minus n. Right. So instead of x of n, here we have used the n into x of n. So this term will representing as the z transform of n into x of n, which will gives you the answer as minus z d by dz x of z. This term will representing as z transform of n into x of n is equals to minus z d by dz x of z. So this way we can prove the differentiation property in the Z domain. Now if you want to find out ROC will be same as x of Z. There will be no change in the ROC. Now the next property is initial value theorem. What is initial value theorem? If I am taking the causal sequence, then for causal sequence, what will be the range of the sequence? Summation n equals to 0 to infinite, right? So n equals to 0 means from 0 we will starting the sequence. So 0 will consider as initial value. So if you want to find out initial value, then it will be found by this theorem. So we have to find out x of 0 by using this theorem. If I am taking the bilateral Z transform or bilateral sequence, or we can say that two-sided sequence, then we can find the value of x of minus infinite, right? So for this reason, we are using the causal sequence. So if I am taking any causal sequence, then the initial value will gives you x of 0 equals to limit z tends to infinite x of z. So this one is the statement for the initial value here. Now if I want to prove this property, so for that, first of all I am writing the equation of Z transform of bilateral sequence, which is summation n equals to minus infinite to infinite x of n z raised to minus n, right? Now here we have to use causal sequence, means this range will convert in the form of summation n equals to 0 to infinite x of n z raised to minus n. Now we have to find out for the causal sequence, so the Z transform for causal sequence equals to x of z equals to summation n equals to 0 to infinite x of n z raised to minus n, because for the causal sequence it will convert in the range of 0 to infinite, right? Now if I am simplifying this term, you can see that instead of n, I am putting the value of n equals to 0, 1, 2 up to infinite. So what will be the term? X of 0 z raised to 0 plus x of 1 z raised to minus 1 plus x of 2 z raised to minus 2, likewise, right? So the next step is by expanding the summation, we can write down x of z equals to x of 0 z raised to 0 plus x of 1 z raised to minus 1 up to infinite. Now if we are taking the limits on the both sides as z tends to infinite, so here the term will be limit z tends to infinite x of z is equals to limit z tends to infinite x of 0 z raised to 0 equals to 1. So 1 into x of 0 means x of 0. Now this z inverse will representing as 1 by z. So the next step will be like this. Now if I am applying the limits in this term, then you can see that z tends to infinite. It means instead of z I am taking infinite. So 1 upon infinite means 0. So for all the other terms, its value will become equals to 0. And here we have not included any term of z, so this term will gives you the answer as x of 0. So the next term will be limit z tends to infinite x of z equals to x of 0. Here we have used the limit z tends to infinite 1 upon z, or limit z tends to infinite 1 upon z square. This all the terms equals to 0, right? So from this we can find out the initial value as x of 0, from which value will starting the input sequence. So x of 0 equals to limit z tends to infinite x of z. So from this value we can find out the first value of the sequence. In the next session I will explain some more properties of the Z transform. Thank you so much.